Okay guys, so in this video we're going to cover how to graph quadratics in standard form. So we're going to start by identifying the a, b, and c value. So a here is -1, b is -2, and c is -8. So since a is negative, the parabola is going to open down. And so the first thing that we always need to do is identify the vertex. So that's the first thing I'm going to do. And when the equation's in standard form, we do that by using the equation x equals -b over 2a, or opposite of b over 2a. So that for me is going to be opposite of b is 2, and then twice a is -2. So the x coordinate is going to be -1. So the x coordinate of the vertex is going to be -1. So I'm going to do g of -1. I'm going to plug -1 in for x to get -1 squared minus 2 times -1 minus 8. And if I do PEMDAS carefully, -1 squared happens first. So that's +1, which I make negative. -2 times -1 is +2 minus 8. And so that gives me -7. So the y coordinate of the vertex is -7. My axis of symmetry is going to be at x equals -1. And so once I identify my vertex, the second thing that I want to do is plot additional points. So to do that, I'm going to go over to -1 and down to -7. And I could make a table if I wanted to. I could put the x coordinate in the middle and the y coordinate in the middle and go 2 above and 2 below and plug those values into my calculator. Or I can use my a value, which is -1, to help me do shortcut method. So normally when I go 1 away from my vertex, I go 1 up. But I need to multiply that by a factor of -1. So I'm going to go 1 away and 1 down. So that's going to bring me here to -8. And then I'm going to go 2 away from the vertex, and normally I'd go 4 up, but I'm going to actually go 4 down because of the -1. So that's going to bring me just a little bit off the graph right there. And then I mirror my 2 points over to the other side, and I join them with my parabola shape. So again, you could use the table, and if I did, I would have gotten that this was -11, and this is -8, -8, -11, or I could simply just use shortcut method. The y-intercept is always my c value, which I can see on this graph. See? And my x-intercept, I actually have none. So this is an example of a quadratic with no solutions. So on page 10 at the bottom, it says number 1, it really probably should have been number 3. We are going to do the problem with a golf ball that's been hit up into the air. So they want me to graph my equation. So I need to start with finding the vertex by doing opposite of b over 2a. And so that gives me +2. So then I'm going to plug in 2 for t to get -16. -16 times 2 squared plus 64 times 2, which gives me a height of 64. And with these word problems, I think it's easier to just make a table to graph them. So I'm going to put 2 in the middle, and I'm going to go 2 above and 2 below. And so 264 goes in the middle, and I'm going to plug 1 in for t. So -16 times 1 squared is going to be -16, plus 64 times 1 is going to be 48. And then if I plug in 0, I get -16 times 0 squared plus 64 times 0, which gives me 0. And I'll mirror those onto the other side. So when I go to graph this, I'm going to do the time, which is the x variable on the bottom. And I'm just going to go every 2 spaces as 1. So I can get some space in between. And then on the y-axis, I think I'm going to go by 4s. 4, 8, 12, 16, 24, 28, 32, 36. That's not going to fit actually. So maybe I'll go by 8s instead. So 8, 16, 24, 32, 40, space 2. So this is 48, 56, 64. So my point here is at 0, 0. 1 matches with 48. 2 matches with 64. 3 matches with 48. And 4 matches with 0. So this is the path that the golf ball takes. So the time it reaches its maximum height. Maximum always means vertex. So the vertex is after 2 seconds. The maximum height at 2 seconds is 64 feet. And so the ball was hit up into the air at 0 seconds and remained up in the air until it landed at 4. So it was in the air for a total of 4 seconds. Enough. So here are the answers to problem number 1 on the next page. So you can see that I had to find my vertex again by doing -b over 2a and plugging that value in to give me my vertex, my highest point. I then made a table to find my other points on the parabola. And then the maximum height, anytime you see the word maximum, it's talking about the vertex. So I used the height that I found and the time I found for when it reached the maximum height. In my table, you can see that I actually went 1 point further because to know when it hit the ground, I need to know when is the height going to end up being 0. So when I had made my table originally, I only went to 25, so that means the ball hadn't hit the ground just yet. So I tried going to 6 to see if the ball had hit the ground at 6 seconds, and it did because the height was 0. So to answer this question, use a table and keep going until the height is equal to 0.